is this is the Cosmology discussion group meeting for December 14th, 2025. Welcome everybody. We didn't have a very good week here. We had a snowstorm on Monday and it kind of knocked out the electricity. So we had a couple of days where we didn't have electricity, and that was unpleasant. And so I didn't really have a lot of time to prepare, but hopefully this will go well. Today I'm going to give a talk about Carl Andrew Zapffe, and he's kind of a dissident. He has some connections to some of the things that we've talked about here in our discussions. Okay. So can everybody hear me?
Yeah.
Yes.
Okay, Carl Andrew Zapffe. Can everybody see this presentation?
Yes.
Okay, I want to welcome everybody here. Before I start, I want to make the point that we need people to volunteer to make presentations. Otherwise, we're not going to be able to continue to go on Sunday. And of course, we're getting up towards Christmas, and I realize it's pretty busy, so maybe people would rather not have discussions during the Christmas holiday or not. Let me know your opinions on that. All right, Dr. Carl Andrew Zapffe. Okay, so here's a big quote from him. It is not right that the finest discipline in the physical sciences should contain within it unnecessary violations of those basic rules of logic and reasoning which belong to the guiding hand of epistemology. And this is a pretty prominent quote from him. I think it kind of sums up his position regarding his opposition to Einstein's relativity. And notice the emphasis on basic rules of logic and reasoning, and which belong to the guiding hand of epistemology. So we've had a discussion. Roger Anderton, says, well, you have all these different points of view, blah, blah, blah. But Dr. Zapffe, who's a dissident, he has the point of view that we're going to use the scientific method, and the scientific method requires logic and reasoning, correct logic and reasoning. He doesn't find correct logic and reasoning in the discipline of relativity. Okay. Well, that's interesting. Gosh. All right. So the presentation is not working. There we go. All right. Who is this fellow, Carl Andrew Zapffe? And I'm going to talk a little bit about this in introduction, but he's born in July 1912 in Minnesota, died in 1994 in Baltimore. Now, here's the important thing. He's got 2 doctorates. Okay, one from Harvard, Doctor of Science, and another one from Michigan Tech. So he's got 2 doctors. He's kind of a polymath, kind of a, how should I put this? Back in the old days, the Middle Ages, the people were called the universal man, who was versed in all kinds of different things. He's a genius. That's kind of a good example of that in the modern era. He was wrote books on the history of Minnesota. He wrote books on the history of the Indians in the Midwest. So and then he dabbled in um, relativity theory, cosmology, um, and but his main occupation was as a metallurgist at DuPont. And then after that, he established his consulting firm. All right, let's see now if we can turn. Oh, now it's working. Okay, so he worked at DuPont and apparently married into the DuPont family. And of course, DuPont family is very well um, high up in social circles. Um, I think that's kind of interesting. So he's apparently not worried about money. Um, his main, what he's known for primarily is during World War II, they were having problems with stress fractures in Liberty ships. And so he established the science of fractography in the 1940s. And if you're people who are in metallurgy, my brother is a metallurgist. He knew who Dr. Zapffe was as soon as I mentioned it to him. So he did work on Liberty ships were sinking because of stress fractures, and he did a lot of work on that. Okay, that's kind of an interesting. So this guy is not a he's not a how should we put it? He's a pretty well trained guy who knows the scientific method pretty well, and he's not a crackpot. I wouldn't call him a crackpot. Okay, his two discoveries. Um, First is the electromagnetic reference frame is a field generated by the Earth and is carried along with it. The field is not a thing, but a condition of the space which surrounds the body generating it. This is pretty uh, interesting idea because he's got some very interesting ideas about electromagnetism, although his primary focus isn't really essentially a new theory of electromagnetism. His his emphasis is the relativity and explaining the null result of the Michelson-Morley experiment. That's his main objective. That's the main thing that he's talking about in a lot of his attempts to publish papers. He did manage to publish a number of papers in journals, uh, but they're not really what you would consider prestigious journals. Um, then his second discovery, which he talks about in his book, um, which I have a copy of here. It's called The Reminder. This is it's upside down. This is the book here. This is mainly the source of most of this information comes from this book. And he says professional relativists do not want to hear about my discoveries. So he was pretty much rebuffed that by the established physics establishment. And he was, I think, very astonished by this because he thought, that he was doing science and that scientists were welcoming, they wanted to learn new things. They wanted to learn they wanted to have science to progress forward. But he discovered that's not the case, that physics was a closed minded group of people. And so his discovery, so he's kind of shocked by this. That's why he calls it a discovery of his. And his book, the book that I just showed you here, this book here, is essentially an attempt to document, the fact that physicists didn't want to hear about, why. relativity and Einstein were wrong. Okay. Now I want to mention here, this seems to be his main operating principle he's operating on, his epistemological assumption. The special theory has continuously produced annoying paradoxes. And despite countless rationalizations that have been offered, any paradox stands as a mark of error. Therefore, something is probably fundamentally wrong about the special theory. So that's a direct quote. So that's his viewpoint. I mean, he's looked at the Einstein's theory of relativity and found that there are paradoxes and things that didn't really make sense, logical errors and fallacies. And so he embarks on an attempt to understand what the heck's going on. And so he talks about um, doing I could say a lot of reading. He bought a lot of books and did a lot of reading. Now, I want to emphasize this part here. This is a book that was owned by Dr. Zapffe. It's Introduction to the Theory of Relativity by Sears and Zemansky. And then I have another book here, Philosophy of Mathematics and Natural Science by Weil, another book that was owned by Dr. Zapffe. Here I have New Light on Space and Time, another book that was owned by Dr. Zapffe. Now, Dr. Zapffe has lived in Baltimore, and when he died, all of his book collection was sold off. All these books that he bought to do this research, this investigation of relativity, wound up in a bookstore in Rockville, Maryland. And so I go to this bookstore, and I was interested in relativity at the time. This was in the 1990s. And I bought these books. I had no idea who Dr. Zapffe was. And the books are kind of interesting in and of themselves by the fact that he's got all these annotations in them. In his I don't know if you can see this, but he's got an annotation in here where there's signed books. Okay, he's got his name in them and signed him. But he's got these sarcastic comments that he puts in the margins of the books where, he says, this is baloney, that sort of thing. And so it's kind of a curious thing. I thought, who is this guy? I thought everybody was a firm believer in Einstein's theory of relativity. Well, I found out that this guy, Dr. Zapffe, didn't really believe in relativity that much. And to make a long story short, I did eventually find out who Dr. Zapffe was, but that's another story in and of itself. And David Toome, I don't know if you're familiar with who David Toome is. He's a participant in a lot of dissident discussion groups. I ran across him, and it turned out that he actually knew Dr. Zapffe and actually had visited him. And so I got into contact with a guy named Jack Graham. And Jack Graham had a lot of Dr. Zaffe's papers. Okay. And so he sent me a collection of Dr. Zaffe's papers. So I have in my hands here a lot of his published papers. So I guess I'm probably the only living expert on Dr. Zapffe other than Jack Graham, who I'm not really sure whether he's alive or not. Anyway, okay, so going to the book, which is the reminder book. Oh, that's here. That's this book here. He describes his journey into relativistic physics. And so this would be the primary source for this information. But he was working on cosmology. So that's the connection with our cosmology. He was investigating Riemannian geometry. I think Vladimir would probably appreciate that. That's a connection with Vladimir's work. And he had this idea that he could explain the redshift in cosmology by um, uh, the fact that there's a three-dimensional space is embedded or hypersphere in a four-dimensional space. There's that word hypersphere again. So he's developed from his studies of hyperdimensional geometry, Riemannian space, and four-dimensional hyperspheric space. That's what Vladimir has been talking about. So he's studying
Yeah.
this, and uh, kind of he's not a proponent of the Big Bang. He's highly skeptical of the Big Bang. That's one of the reasons why he's doing this. And I suspect he's like me. He couldn't really understand why these physicists who are supposedly smart people are believing in the expansion of the universe, that the space is expanding. What does that mean? And so then he talks about his 3-year study of special relativity produced a growing conviction that Einstein had made a serious mistake. So that's kind of the background for how he got into looking into special relativity, which makes sense since special relativity is the foundation of general relativity, which is the foundation of cosmology. The Einstein error. Now, this refers to a title of the manuscript that he produced that was rejected over and over by numerous journals with no reasons given. Now, he says that he submitted this to a couple of hundred different journals, or I'm not sure I really believe that it's really a couple of hundred, but it was a lot of journals. And and they just said, well, they'd send him back these rejection letters, but they really didn't ever tell him why what he said was wrong. uh, Apparently never got to the stage of even being submitted to a referee or a reviewer, and the reviewer would write, lots of times the reviewers would write, this, you need to correct this, or this is not right, that sort of thing. He would just get rejection letters, and he couldn't really understand why. What am I doing wrong? So the next point is no one was able to tell him where he went wrong. He is convinced that Einstein was wrong and submitted these papers thinking this was a really big discovery. And he'd get all these rejections on these scientific journals, but nobody would tell him why he was wrong. Nobody would explain to him why he was wrong. And I think this is one of the big issues with dissidents, um, because nobody can really tell us why Einstein is right and our criticisms are wrong. And they don't really fully, the mainstream doesn't understand this. They just think, well, you're wrong because we say so, or you're wrong because experiments prove Einstein. But the more you dig into it, the less convincing it all becomes, because there's no real explanation of why you're wrong if you think Einstein's wrong. Um, and his big comment about this, now this is where it kind of comes into the discussions that we've been having. Um, Nowhere in the literature did the relativist address the idea that the magnetosphere was the reference frame for electromagnetism. That's his scientific idea. His idea is that the magnetic field of the Earth is the reference frame for light velocity. And this is an idea that's probably more familiar to us now. Um, but at the time, remember, this was in the 1960s. They didn't have a GPS, and all they had was really the Haefel-Keating experiment, which he talks about in his papers. Um, so this was his idea. He had this idea, and in a way, this is sort of completely the antithesis of what modern physics, cosmology, and astronomy. Their approach is everything has to do with gravity. General relativity is about gravity. Astronomy is all gravity, planets orbiting And in those days, gravity, if you were studying cosmology, cosmology was all about the theory of gravity. The theory of gravity was general relativity. Nobody was thinking about electromagnetism as having any real significance or importance to cosmology. And so I think one of the takeaways that I want to um, point out here is that Zapffe is one of the first people to bring up the idea of what we would call today the electric universe, which I think is a more familiar term to people. So I think Dr. Zapffe is kind of a pioneer of the idea of the electric universe, where he was saying um, things from a magnetic and electric point of view, an electromagnetism point of view. So the Earth and its environment, the Earth is surrounded by a magnetic field, and that magnetic field is the reference frame for light physics. And so, from that idea, the speed of light is defined by the um, field of the Earth, and then any attempt to measure the velocity of the Earth electromagnetically using the Michelson-Morley experiment would have to fail because the reference frame is not the heliocentric reference frame; it's the geocentric reference frame, which is the reference frame that sets the velocity of light. So therefore, the Michelson-Morley experiment would fail, and so that was his big discovery, and he thought the physics community would really be interested in knowing this, and he found out that they didn't. And so now we're going to talk about the Waterloo, Canada presentation. And he joined this physics organization, and they accepted his paper, one of his papers, for a presentation at this conference in Canada. And so, with great anticipation, he went to this conference in Canada and gave a presentation. And he was met with stony silence and hostility. And one of the comments was that you are the only one that contradicts Einstein. I mean, they were not at all receptive to his ideas, and he felt very unwelcome. And he talks about how he just wanted to get the heck out of that place because it was such a um, unfriendly reception that he got when he presented his theory. And he says that his reaction to this was that his admiration for theoretical physics rapidly turned into disgust. So let's see here. All right. Now I'm going to talk a little bit about what he did wrong, why he failed. And probably one of the things was that he was being a metallurgist was not really how should I say it, was not really in tune with the style of the way theoretical physicists were doing things. And so there's this, his terminology is kind of, how should I put it, unusual. Um, I, I, I think his way of thinking and his approach was completely different from what theoretical physics the way people write papers for theoretical physics. You have to remember this guy's an experimental metallurgist. Okay, he's an experimentalist. And so his experience is and metallurgy is kind of, and it's an engineering. It's a practical engineering applications of metallurgy. So he considers himself an engineer, and so he's not really tuned into the way physicists do things, and um, uh, he doesn't really present his ideas in a way that physicists would expect to have a theory presented. So he doesn't really conform to their rules about how to present a theory. And one of the things, if you read his papers, his methodology is kind of vague and unclear. And you sort of have to read between the lines. Um, and so that's another issue. He's not particularly good writer. His papers aren't particularly well written. And that's one of the pluses for Einstein. If you read Einstein, his prose is very clear, and his ideas aren't very clear, but the way he presents them makes them sound plausible. Unfortunately, Dr. Zaffe's work it seems sort of kind of like a hodgepodge, and so his prose style is also kind of, how should I put it, difficult. He has, in English, you're told not to use run-on sentences, and a lot of his papers are full of run-on sentences. And what I found myself trying to figure out what he's talking about, because he'll have a sentence that goes on for a paragraph, just a big long run on. He strings a bunch of ideas together, and you get these long run on sentences. And so it's very difficult to really read what he's saying. So that you can understand as a reason for his initial rejections. But he did improve in his writing style, and managed to get a number of papers published in the later 1970s and 80s. Um, the real problem I think that you run into is that they ran into at the Waterloo conference was, we know what we're doing, and who are you to say that Einstein was wrong? And so the attitude is, we are right and you are wrong because we say so, therefore you are wrong. That's my um, they're just they're we're right. Einstein's right. We're physicists. We're the experts. We know Einstein's right, and so you can't be right because we know you're wrong. It's kind of this is a prevailing attitude that you have in the physics community, particularly with respect to Einstein. Um, One of the examples of this is um, uh, you'll see in the literature, people will say, well, anybody, when I get a paper from a person who is going to show me why Einstein was wrong, I know his paper is wrong before I even read it. So they have an attitude that anybody who is critical of Einstein is wrong, and that's their attitude at the start. So you're basically behind the eight ball before you even get an attempt to present your argument. Okay. And then I think the other last issue basically is to embrace Dr. Zaffe's theory required a major paradigm shift for all of mainstream science, since it required admitting Einstein was wrong. So he is basically asking people, to accept a major paradigm shift, and that would do away with general relativity, special relativity. They'd have to rewrite all the physics books. They'd have to go back to square one with a lot of their work. And his arguments really weren't that particularly convincing to justify doing that. So there's a lot of resistance to that. Okay, I'm going to sort of try to summarize here. We're getting towards the end. Now, I have a two-part presentation. I'm going to talk a little bit more about Dr. Zapffe. This is really basically a introduction to his ideas, and I didn't really put a lot of technical detail into this part. If people are interested, we'll talk more about the technical details in a later session. Okay, so I think the main issue here is that he starts off with an objection to cosmology. And that has to do, of course, with his idea that the redshift could be explained without um, recourse to the idea that the universe is expanding. Now, this, of course, is essentially denying that general relativity is correct, because the idea that the universe is expanding is basically comes from general relativity being consistent with the measurements of redshift. And so um, I think he didn't really like this idea very much at all. He didn't like the Big Bang. I think he really was looking for some evidence that he could bring forward that this cosmology, this idea of the Big Bang and the current approach to cosmology was wrong. And I think that's kind of what his motivation was in his attempt to research, what is the basis of Einstein's theory? What is the basis of general relativity? Why are scientists believing these ideas which are strange and outrageous? Um, but what happened was as soon as he started digging into the history of relativity, he started running into all these books. Like he's reading all these books. This is an example of this book. This particular book, Introduction to the Theory of Relativity by this is a really strange book. And if you read it, you could get completely, I mean, it's completely confusing. And and you could tell by his annotations in the margins that he didn't really buy any of what they were saying. So he looked at a lot of books. This is a anti-relativity book by Dewey. So he investigated not only the theory of relativity but objections to it. But in doing this, he got sidelined from his main goal, which was he was investigating cosmology. And so then that put him on this long journey as a sidetrack of why Einstein was wrong, why the whole theory of relativity was a mistake. And uh, he wasn't really particularly successful with that. Okay, his conclusions agree with the idea that there must be an absolute frame for measurement of space and time, and that the Earth's magnetosphere defines that absolute frame. Now, the dissident community has sort of become fairly familiar with this idea now, particularly with GPS and the work that Ron Hatch did. And I guess today, this idea that Dr. Zapffe came up with, um, which was basically an extension of the Stokes ether theory idea that the Earth carries around the ether with it. And Dr. Zaffe's idea was that not that there was an ether, but that the frame of reference for magnetism, for electromagnetic waves, is the magnetic field of the Earth, which is kind of a hard to understand how that can be. Um, and I can think of a lot of objections to it and a lot of reasons why it shouldn't be accepted. But you really kind of have to also understand his electromagnetic thinking. And we'll talk about that a little bit more later in the next session. So his idea is we can get rid of the theory of relativity and the Lorentz transform because we don't need to explain the Michelson-Morley experiment anymore. So his idea was that the Michelson-Morley experiment is the genesis of Einstein's special theory of relativity. And since we don't need to explain the Michelson-Morley experiment because the Earth is at rest and relative to the electromagnetic frame of reference. So the speed of light is constant in the frame of the Earth, and we wouldn't expect to have any positive results indicating the Earth is moving around the sun because the frame of reference or the ether rest frame, if you will, remember, he didn't believe in an ether. He had this idea that the reference frame was electromagnetically defined or defined by the magnetic field. And therefore, we don't need the Lorentz transform to explain the experiments. And since we don't have the Lorentz transform anymore, we don't have the theory of relativity, and the whole relativity enterprises collapses. And that was his thesis. Okay, we're coming up to the end here. Got about 5 minutes.
I'd like
So does
to
it?
just add something quickly. We've just recently discovered the electric field that the Earth generates along with the magnetic field. So I don't think he was too far off in his ideas of magnetism, and
Well,
possibly
I
the
was
reference
gonna,
frame being that.
right. I agree with that. And I was going to talk about that in the second part.
Oh, okay.
Um,
I'll shut up.
but you made a good point, and that's kind of the reason that I'm bringing up Carl Zapffe, is because I think some of the ideas now that are changing are more consistent with some of the things that he was talking about. And I think some of the things that we understand today are more consistent with his theory than the evidence would have been in the 1960s and the 1970s.
Well, we know much more now than they did back then. So,
Just a brief response. I had never heard of Dr. Zapffe until you brought him to my attention, Harry. And when I looked a bit into it, I was actually quite struck by how similar his ideas were to my own, if I may say so. Apart from the fact that he shares my birthday, he was born exactly 40 years before I. You may be coming to this later, but he did have some interaction with NASA, and I understand that he seemed to be getting somewhere, and then suddenly they just dropped correspondence. They wouldn't respond to his ideas. He wanted to do some experiments which might be similar to what Jim Morrison often expresses, maybe do some Michelson Morley type experiments in outer space, but they just stopped engaging with him.
Yeah, that's a lecture in and of it. That's a whole lecture right there just to discuss that. I wrote
and
a
I'm
paper about that, and that's at the GSJ, the General Science Journal. I don't know if you've seen that or not.
I think I may have seen it. You have to pardon me because it's probably some time since I looked at these things, but I think I did see your paper all right.
I'm I'm
Uh,
fair I'm fairly knowledgeable about the electric universe, and I've never heard of Dr. Zappi. Correct me if I'm wrong, Ito. Have you heard of Zappi's work in the electric universe, regarding
No,
the electric universe?
no, I have not, but I like the presentation so far very much. And I think what we're dealing with here and why we're resonating, like myself as well, is that, there's logic involved here. And in the mainstream, I would dare say, as I pointed out in my own presentation, people start out with the rhetoric, then go to the logic, and then go to the grammar or the observation. That is the wrong way around, and that is mainstream. And I think this gentleman that we're talking about, had a good set of mind and did proper thinking. That's my response so far.
well, I'm glad you said that because that's kind of the idea I was trying to convey. This guy's a smart guy. I mean, he's a genius. I mean, he's a on the level of Einstein as far as brain power is concerned. And he's sort of like a polymath, and then so he's thinking, I'm going to look into cosmology. I don't understand this Big Bang thing. Doesn't make any sense to me. And he
Right.
starts looking into that, and then the next thing you know, he's going like, well, what's this relativity, general relativity? What's this special relativity? And the more he digs, the more things he finds that he doesn't like and he doesn't agree with.
And I think that is the thing that I guess I was referring to. Thank you for that response again, because that is my experience as well. The further you dig into it, in the stuff that and I think you mentioned something with him as well. At first, he was an admirer of physics in general, and then it became detestable. Why? There's simply a lot of untruth, wrong thinking, prestige, narcissism, etc., involved. It's detestable when you're true at heart, trying to do scientific work, that is. And I think,
All right, we're
so
coming up to the end here.
I've seen that
Don't
with all of you, right? Logic thinking is critical. Then you
Right,
can be that omnipotent researcher, if you will. I'll shut up
don't you
now.
know?
right. Okay, we're back. I think Ito got the main thrust of my presentation very well. That was
I'm eager to hear the rest of it, sir. Very much.
okay. Does anybody have any uh, comments that they would want to make on the first part, and then I'll try to dive a little bit into the reason I brought Carl Zapffe up was the discussion, I think it was a couple of weeks ago, about Vladimir and Rick were talking about the electric universe and some of his ideas. And I was struck by some of the things that people in the electric universe and some of the modern ideas that Vladimir is talking about sounded a lot to me like the sort of thing that Zapffe was trying to present to the physics community, but he wasn't really having much success doing that. And his inspiration, if you will, was the aurora. Um, and he doesn't really document. It's kind of not really vaguely documented in his published papers, but people who knew him say that he was inspired by the aurora, and living in Minnesota, and he saw the aurora, and it kind of came to his mind that we're living in this protective envelope, that the magnetosphere is a protective envelope for the Earth, and that this protective envelope is part of the Earth and extends out from the Earth, and that this could be an explanation for the null result of the Michelson-Morley experiment. So his inspiration is really is electromagnetic inspiration. It's not a gravity-based inspiration.
Well, Christian Birkeland, the discoverer of Birkeland currents, did exactly that. He went to the North Pole and studied the aurora and determined that they were currents that were the Earth was receiving. He did the initial work in the late 1800s, early 1900s until 1902, when he passed away in Japan, a broken man, basically, because nobody would listen to him.
Well, that's the same thing that happened to Dr. Zapffe, yes.
But I think the central point that came to his attention in regard to the aurora was that it wasn't rushing by. There wasn't an aurora wind. And that gave him the conception, as far as I can understand, that the effects of the aurora were captured within the Earth's electromagnetic frame, which was moving with the Earth.
Right. I don't think the physics people really, I don't think they wanted to hear this, and I don't think they, then the other point that I was trying to make is he kind of presents this in a way that isn't really, you have to understand his inspiration and to understand what he's talking about. He's not, his communication skills aren't that great. That was the point I'm trying to make. That's one of the difficulties. So reading his papers and his work, is you have a lot of problems with these run-on sentences and these cumbersome constructions of sentences and ideas, and it's not really presented in a way that that an editor of a scientific journal would read and say, "Oh yeah, I really want to publish this paper." I think the typical editor would say, "Gosh, I don't really understand what he's talking about. There's no way I'm going to publish this paper."
Well, I think reference frames is the issue here. I think when you start talking about reference frames and getting into philosophical and mixing it with standard, experimental physics and calling it reality, that's the problem. It just doesn't make any sense, these reference frames. Talking about the speed of light in reference to this or that, or it's just nonsensical thinking. In my view.
Okay, so Dr. Zapffe would agree with you because that's pretty much what he was trying to say. And kind of the point I'm making about this is that you can see places where he says what you just said, but he doesn't say it in a way that communicates the idea very effectively.
Well, you
Well,
just have to drop the idea of reference frames altogether and just say we're on the Earth. There,
Zapffe also advocated an absolute frame, which is a type of reference frame. I would think the absolute frame that he talked about is more of a preferred frame, because I don't think an absolute frame that for the whole universe exists. That's my
See,
view.
here we go. Absolute, using other words to describe different frames. It's just convoluted nonsense, in my
I
view.
don't think so at all. I mean, they serve a direct purpose. I mean, they're used all the time in I mean, in science. I mean,
Yeah, well, they're used all the time in Einsteinian science.
well, I mean, an inertial frame is a frame. Okay, like Newton's laws. That an object goes in motion and stays in motion at a constant velocity, just indefinitely, and then an object at rest stays at rest. That's the same. That's the same basic concept as the principle of relativity, where when there is an acceleration, there's that equilibrium that's there. Where there is an acceleration involved. Those
And
are frames.
that's physically known. That's
Those are
experimentally
frames,
known.
Rick.
Yeah, but it only frames are only necessary when you're talking about mathematical equations. When you're talking about reality, math can
Math doesn't make it a
describe
part of the
reality,
reality.
and it can also describe falsehoods. It can also describe non-reality.
Well, I
Uh,
agree that frames
so
are invisible, but they're useful constructs.
only in math.
I mean, apart from math, I mean, I'm not a mathematician and I use them.
Yeah, okay. So you've really brought up the issue that Dr. Zapffe was trying to make. And we see here in the discussion, it's not an easy, um, it's not easy to explain or to resolve, the differences of thinking. But that was one of his objectives, was to try to get rid of the idea that we should use inertial frames as frames of reference for physics. And he wanted the frame of reference to be a physical frame of reference, something that was real, not something that was an imaginary mathematical construct. He
Like the
wanted
Earth's
something,
magnetic electric field.
right. That was real to Dr. Zapffe.
Yep.
And the Earth was real to Dr. Zapffe. The Earth's environment was real to Dr. Zapffe. And the Earth magnetic field of the Earth was associated with the reality of the Earth and the Earth's environment, and it was part of the Earth and the Earth's environment. For him, that was a real frame of reference,
Yeah.
not
Well,
not a mechanical or inertial reference frame, which was a idealized mathematical construction.
well, I would say the underlying principle of a frame is present within those conditions, though. Within the Earth's frame, or in any celestial object, or even a frame in outer space, whether it's accelerating or stationary, so-called stationary, or traveling at a constant velocity. That's my view.
Well, anyway, the physics community didn't like what he was saying. That wasn't their approach and the way they do things. They were doing things with these idealized frames of reference, these inertial frames, um, uh, and idealized mathematical conceptions. And Dr. Zapffe didn't like that at all. Remember, he's an experimentalist. He's a realist. He deals with the real world. He didn't like all this imaginary um, mathematical idealizations that had no real physical reality. He didn't like that. That was, I think, a large part of what he was objecting to. And you can imagine him going to a physics conference and trying to explain to people, you're doing everything completely wrong. You shouldn't be doing what you're doing. You're completely out of touch with reality. You should be using the way I say you should be using. And they basically didn't get it. Not only did they not get it, that made them angry.
He should have realized that, though. He should have known that beforehand, you'd think.
No, but you have to realize that Dr. Zapffe is a genius, and
Yes.
he's thinking, I'm a smart guy, and I've made this amazing discovery that's earth-shattering, and I mean the whole scientific community is on the wrong track. Everything that they're doing is wrong, and he's thinking that they would be eager to learn this, but he discovered they were not eager to learn it.
So
Well,
I can't
he's
help wondering why we don't know more about him. I mean, I'm thinking conspiracy, even whether the mainstream have succeeded in hushing him up, because we know about Dingle and they bring him up to put him down and contradict him, and even Essen, a lot of other people, but never heard of this man at all in the literature. They never say, well, there have been some cranks, and here's one of them, Dr. Zapffe. He's completely unknown, and I'm wondering, is that successful dumbing down by the establishment? I'm just wondering that.
That's a good question. I did write a number of papers about this at the GSJ, and there was no interest. I did get a email from a fellow that said that you made a mistake, and I published his a copy of the reminder on the GSJ, and apparently I made a mistake and deleted one of the pages and when I published it. And the guy said, well, you forgot to include page 41. And I said, oops, that was a mistake on my part. And that was the only comment I got.
Henry, thank you very much for this unknown but genius physicist. Genius. Because what does it mean, genius, always? This is ideas based on nothing. We know so much right now, and I have the same idea like him. But he was much ahead of me. He didn't know about microwave background radiation and all this stuff. But what is important? Let me tell you my understanding of his genius approach. He proposed hypersphere as the word, Riemann. It was my first reference on Riemann, in my papers, but I never heard about him, and I did refer to him because I didn't know about it at all, because I didn't see any reference. I didn't see maybe your papers. That's why I don't know about him. The very second point is, guys, the most important are ideas, and ideas very simple. Hypersphere, absolute time, and absolute frame. Not frame, absolute space. Guys, I do like very much the even notion frame. Frame immediately means you have some 0 point in the frame. There is no, in cosmic medium, there is no such a 0 point. There is the whole space absolute. You see what I mean? That's why even discussing preferred frame, this frame, ideal frame, mathematical frame, it's a wrong word, wrong notion. Because there is absolute space, means whenever, where you will measure something, you will see the same result, and it doesn't matter where you will do it. You don't need to put the 0 point in any place. You see what I mean? That's why I like him very much. Absolute space, time, and hypersphere. These are the main ideas of my model. But I have only one question to him. Did he refer to Dirac in his papers?
Not that I know of, but I have to say, um, I only have a small selection of stuff that he published. Apparently, there was some papers published in journals um, that I haven't seen, and I haven't really read all of it, to be honest with you. Um, so there could be some mention of it in this reminder. I haven't, I didn't really read this whole thing in detail, okay, in preparation for this talk. There's a lot in in his paper. He talks, and he may mention Dirac in here. Um, uh, I'd have to, there's nothing that really comes to mind that may be in there. You know, this apparently is you can get copies of this, you know, on Amazon. There are used bookstores apparently that have copy of this that you can get. Um, there's a lot of material in this book. I mean, it's difficult to read. Okay,
Okay.
particularly it's a kind of a tutorial, and he talks a lot about historical stuff. It's he talks. It's a lot of material. Okay, it's not.
And what
I've
about
just
Nicola?
given
Uh-huh. I'm
I've just
sorry.
given a surface. I've just given a surface discussion. I mean, there's a lot there that's below. You know, there's a lot of detail that I didn't even go into.
It's a detail. The main point are, as I told you guys, and I'm looking always deeper, much deeper to people ideas. How he will realize what are the details, it's another story. But I mentioned already his ideas, and I'm so happy about them because really he was a genius. What about Nikola Tesla? Do you know something about Nikola Tesla in his papers? Because he was absolutely against Einstein. He told that everything depends on ether. He wasn't there. His main idea was ether, and it doesn't mean only the medium. The influence of ether, absolutely right. Absolutely, we must take into account, and that's why neglecting ether it was absolutely wrong from Einstein and from other guys and so on and so on. That's why I ask this one because in Dirac and in the Tesla. Dirac, by the way, Nobel Prize laureate in physics. Nikola Tesla, well-known physicist. Nobody wanted to accept these ideas. What you were talking about Dr. Zapffe? Who cares about him? If Nobel Prize laureate in physics became who crazy guy, he has to move to America because he was crazy for Europe. That's why acceptance acceptance of these genius guys never happened. I know history of physics so good. Yeah, I know so many different guys, much earlier. No, never accepted them. And now all of them forgotten or crazy or something like this. This is my main point. It's Dr. Zapffe, it's only one of them. That's it. It's nothing unique.
Well,
I'm not
one of
talking.
the reasons why he has fallen into obscurity, maybe because he wasn't principally a physicist. You know, modern scientists and all learning is so compartmentalized that one, side doesn't talk to the other. We talk about these silos, and people like Tesla or Dingle.
You're a
Then,
physicist, Nobel Prize laureate
yeah,
in physics, and nobody
well,
wanted to accept him.
but the fact that this guy was principally a metallurgist, or maybe the most famous work that he'd done was in metallurgy, they just dismiss him. Had he been principally a physicist, they'd probably be writing books on him now and trying to, discredit him.
That's an interesting.
I am not a cosmologist. I'm laser physicist by education. And it does mean that I cannot generate ideas in cosmology. The same story with Dr. Zapffe. The same story, guys. It does matter, metallurgists or laser physicists or something else. No, what does matter, deep inside of them, what kind of ideas they develop, they accept, and so on and so on. And then if he is not right, correct him. Simple like this.
Okay, if we got some time here, I'm not sure whether I think he's frozen.
No, it's okay. Please continue.
Okay, all right, I'm going to go and let's see if we can. I'm going to continue on a little bit and go to the second, and hopefully this will work here. Um, okay, so here's um, I'm going to talk a little bit about electromagnetic theory. Hopefully, I can slideshow. Okay, we got slideshow. Now, one of the things that is kind of puzzling is that he does have an electromagnetic theory, but he he's got these ideas about electromagnetism, and they're kind of mixed in with his um, uh, whole theory, and it's not a how should I put this? It, it it you have to sort of know something about electromagnetism and really understand what he's talking about to really make sense out of it. So he's got an electromagnetic theory that isn't the established electromagnetic theory, that he doesn't really break that out as a separate theory. In other words, you would thought he would say, okay, here's my theory of electromagnetism, and then and build the theory in steps. He doesn't do that. It's kind of mixed up. So what he does, and this is kind of interesting, he says he postulates the existence of a Maxwellian field responsible for establishing the reference frame for light propagation. And first thing, of course, is what's a Maxwellian field? Well, he never defines what he means by a Maxwellian field. Okay, so there's a problem there. I could see where somebody, a reviewer or a physicist reading this go, there's no such thing as a Maxwellian field. This guy's a crackpot. So he's basically created his own terminology. This Maxwellian field is a terminology that he's created and doesn't really define it and doesn't explain it. So that's a problem. And his idea is that the Maxwellian field replaces the inertial frame of reference of mechanics postulated by Einstein as the physical frame for light propagation. So we talked about, Rick talked about this. His idea was he wanted a physical frame of reference. He didn't want an inertial frame, a mathematical fictitious frame. He wanted something real. And his thought was that to him, the Maxwellian field was reality, was physical reality. Okay, and that
Sorry
was,
for disturbing you, sir. I'm very sorry. He talked about field. It is not a reference frame. It's a field. It's a space.
well,
And you can, instead of his Maxwellian field, tell microwave background radiation. It's a Maxwellian field from his point of view. I'm
I'm
sorry.
showing I'm showing an image of Christian Birkeland's Torellus experiment. That's the field that Vladimir's talking about, that electric magnetic field.
It's a microwave background radiation, guys. That's it, simple like that. But there is no frame. There is a whole space because
Bingo.
you cannot go with your it doesn't matter. Electromagnetic waves with you don't need this frame. You need only medium, some ether, cosmic medium, whatever, but medium to go with all your electromagnetic waves. There is no reference point.
Okay. Let's just, the point I'm making here is that he's thinking his idea isn't really as particularly well formed as you're talking about, Vladimir. He's trying to, like I said, this idea of Maxwellian field. What is it? It's not really well defined. He doesn't say, and it's kind of cumbersome to try to understand something that isn't particularly well defined. That this is an idea that he has that he's trying to develop and to present, and it's he doesn't really achieve a very good he doesn't really explain what he means by this idea, but it's behind what he's talking about, that this Maxwellian field is something that's created by the Earth. Okay.
Not just the Earth. The sun has this same pattern that you're seeing on my
right.
picture.
Well, let
So
me
does
let me get
galaxies. Go
get
ahead.
to that. You're jumping ahead of the story. You keep jumping ahead of the
Yes.
story.
Sorry.
Sure, but the main point, my point is field, Maxwellian, whatever, but field, there is no frame. Sorry, please continue.
Well, Dr. Zapffe has, and I think he has this idea that the field is a state of space. It's something, and it's kind of hard to get to what he's talking about. And
Yes,
Maybe a
I agree
property of
with him.
space?
no, I think later on, I have but I want to sort of um, what he thinks a field is isn't really, he doesn't really define it very well, but he thinks of the field as something that is a condition of space, if you will. And this condition of space is created or comes out of the earth. So, in other words, it's a physical thing that is associated with the earth and the existence of the earth. So he's kind of like, an ecologist in the sense that he sees the earth as being this unified entity, that the earth, it's the material, the lithosphere, the hydrosphere, the atmosphere, the magnetosphere. This is all part of the earth system. And one of his criticisms of physics is that physicists don't really appreciate the entire story. They're just looking at things, in terms of reference frames of empty space. And he sees that as not really physics. It's, for him, you have to look at the whole um, ecology of the earth, if you will. The earth as a whole, all of the sciences that are involved in that, geology, geology, and hydrology, and electromagnetism, as far as the magnetic field is concerned. So that's kind of his idea. That's not the way physicists are thinking about things. That's kind of the main point there. All right, now here's where his idea is to get rid of the Lorentz transform. Now we talked about this before. The Lorentz. He has this sort of idea that if you can get rid of the need to explain the Michelson-Morley experiment, then you don't need the Lorentz transform anymore. Okay, so we want to eliminate the Lorentz transform. And once we get rid of the Lorentz transform, we don't really have special relativity anymore, and we don't need Einstein. We're not talking about time and space varying and space expanding and you know contracting and time dilating and all these things. He says all these things he thinks of as being artifacts created by the Lorentz transformation. Now, one of the points is that he's equally as critical of Lorentz as he is of Einstein. And that's kind of interesting. So he wants to he get rid of the Lorentz transform. That's what he wants to do. Now, of course, as I pointed out previously, getting rid of the Lorentz transform is going to be really difficult because it's used in electromagnetic theory. It's used in nuclear particle accelerators. It's pretty extensively used in physics, and it's become kind of indispensable to the physics community. So a proposal to get rid of the Lorentz transform is obviously going to get a lot of resistance. Okay. I want to talk a little bit about, and you were, the GPS, or new modern ideas about the GPS of the ECI reference frame. This is consistent, I think, with the geocentric reference frame or his Maxwellian field concept. Okay. So, he didn't know GPS didn't exist when he came up with his theory. So we could sort of see this as kind of tend to a confirmation of his theory. Okay, now there's this, he had this idea that there was a hierarchy of these frames. Okay, that the Earth was a frame, um, a Maxwellian frame, and the sun created a Maxwellian frame, and that all the planets created their own frames, if you will. And of course, now we have this idea that they've told us that they've discovered an extended heliosphere that goes out beyond the solar system. And that would sort of tend to confirm the idea of this hierarchy of frames which Zapffe had. Now, he did in his papers show diagrams that show this hierarchy of frames. And this is kind of an idea that's not really alien to us today, but I think in when he did publish these papers in the late 70s, early 80s, this was kind of something that was completely new and different. I think nowadays we're becoming more familiar with the idea of magnetism as being important to cosmology and astrophysics than when Dr. Zapffe was doing his work. And that would have been in the early 60s and 70s. Magnetism wasn't really viewed as being that important to cosmology and astrophysics. Okay, then we're back to the mistakes again. Um, I think he thought, well, I'm getting rid of the Lorentz transform, and people should welcome this. But I don't, that I think kind of may have been a mistaken idea on his part. Getting it's hard to imagine the physics community just throwing away the Lorentz transformation. I have a hard time imagining how they could accept that idea. So I think there would be a lot of resistance to the idea of getting rid of the Lorentz transform. It's just way too useful to them. And they use it quite a lot in engineering. It's kind of become an indispensable tool in high energy or high velocity relativistic physics, as they call it.
But as we said on a previous occasion, if I may just interject there briefly, Harry, could be considered as a useful substitution without having any real physical value.
Well, like I said, I think he thought that the Lorentz transformation was a stumbling block for physics, and that getting rid of this stumbling block, that the Lorentz transform was really the cause of all the paradoxes. I don't think the Lorentz transform is the cause of the paradoxes. It's the misapplication of the Lorentz transform that produces the paradoxes.
Bingo.
And I don't think he really appreciated that difference. Okay. And so by attacking the Lorentz transform is sort of like going and attacking a cherished piece of physics belief. And I think that was, I don't think he was really going to get very far with that. That's kind of my point.
If you look at the Lorentz transformations as sub-transforms within a real transform that work for electric engineering, then you can keep it. You don't have to get rid of it. You just have to look at it as sub transformations within the reality transformation itself. You have to think of it that way.
Well,
No.
all right. Well,
One
anyway,
sec-
I want to finish up here because we can continue on discussion later. We only got about 5 minutes. So the other point I wanted to make was he didn't really appreciate the difference between the Lorentz ether theory I don't think he really quite understood the difference between Lorentz's view, which was based on the absolute frame of reference idea, and Einstein's view. I don't think today we have, a better definition of what's called Lorentz ether theory. And I don't think he even knew anything about the Lorentz ether theory. So, from his point of view, getting rid of the Lorentz, both Lorentz and Einstein were wrong. That's kind of his position. Okay, I think what is, down at the bottom here he thought that his geocentric theory explaining the Michelson-Morley experiment would lead to getting rid of the Big Bang cosmology. And I think that's kind of what his ultimate goal was. He just did not like the Big Bang Theory. He didn't think that was really a viable idea. And I think that his whole attack on relativity is sort of motivated by that. Then we have sort of kind of a summary of some of the things, some of the ideas that he had that really didn't work out. One of them is this Maxwellian field idea. It's kind of obscure and not really clear what he was talking about. So, obviously that didn't go anywhere. Okay. Then the speed of light is defined by the local Maxwellian field, not by an inertial frame. Now, we talked about this, and it really didn't persuade anybody to this idea. In other words, he was really trying to say to the physics community, inertial frames have no physical reality. You need a theory that really is based on physical reality. Physics people didn't see that. Now he had this, I didn't talk about his model for the aberration of starlight. Um, that really created a lot of opposition. Okay, there was a lot of criticism when he started talking about how his model could explain aberration of starlight. There was like a lot of objections to his aberration model. So his aberration model isn't very clear and not very well defined. So that was kind of, I would think, a failure. Then he had his concept. Okay, so here's the hierarchy idea that we were talking about earlier. He had this hierarchy of these Maxwellian frames. And, every planet, every star has its own reference frame or frame of reference or environment, okay, that defines physics in the context of its own environment, so to speak. And that idea didn't catch on at all. I mean, it just kind of disappeared. And we only know about it by going back and looking at his papers and seeing his diagrams where he has this hierarchy described. Okay, we're going to get cut off
quick
here.
interjection.
Yes.
This is basically how I see the nucleus or the atom, if you will. It is a thing on its own, right? Separated from all the others. So a universe on its own, a frame of reference on its own, etc.
Yes, this is an
Very
idea
awesome.
that really should not have been thrown away.
Yeah.
Okay.
Hey, close, 1 minute left. Please close your discussion, your
Okay.
conclusion.
Awesome
Okay.
concept.
Well, I'm
Don't
just
interrupt.
okay. Then we have some biggest. Why don't we talk about some of these other things in the next session here? Okay, we got
Okay.
it looks like 2 minutes to go. The hierarchy idea, I think, is it's in his diagrams, but he doesn't really emphasize that very much in his theory that what he's talking about. And so it's something he mentions it in passing. A lot of his ideas, and this is kind of hard to picture. He has these ideas and he kind of brings them in to his papers when he's talking, but they seem to come out of left field and they don't have any real explanation. And that's his papers and his thinking isn't really organized enough to call it a theory, or any of his presentations a theory. They're just ideas that are being thrown out, and here's an idea and here's another idea. And he kind of has these ideas and they're all kind of cobbled together into a paper. And they're not really well presented or well organized as ideas. And I think that kind of explains why his papers really didn't find any acceptance and okay, so we're back. I got long-winded there. I should have been more careful. All right. Pretty much what I have rest is just to elaborate some more on a lot of ideas that are kind of a mishmash. Maybe that's not an unfair description, but maybe not unfair entirely. A lot of ideas that he had in his head that he's trying to explain to people, and the ideas are unfamiliar, and there's a lot of different ones, and he's got ideas on electromagnetism that are kind of outside of the mainstream, and he has ideas uh, about how physics should be done that is outside of the mainstream. So it's kind of something that you really, if you're interested in pursuing, you'd have to do. You need a lot of reading to really kind of pin it down. But he's got a lot of ideas that we are not at all today unfamiliar with. And we can sort of spot these ideas in his papers and identify what they are. They seem more familiar to us today than they would have been to physicists in the 1960s, 70s, and 80s. All right, dead silence.
Well, yeah, I agree, because they're starting to admit to more electric current in the universe. They're starting to see that these magnetic fields that we visually see through telescopes now have to be generated by moving current. And shells within shells within shells is how the universe runs. I have a picture of a galactic current situation set up on my picture. You can see the current going in through the arms and going out through the galactic jets. That's how everything works. It's a torus field.
Right. Well, we're more today. In Zaffe's day, what he was talking about was very, compared to the sophistication of this diagram, what he was talking about was very, very crude and primitive, and very unfamiliar to people in theoretical physics that were doing cosmology and that sort of thing. And the people who are doing cosmology are basically steeped in general relativity, and that's pretty much their area of expertise. The whole universe is based on general relativity. It's Einstein's field equations that are the important physics that defines the universe. And here comes Dr. Zapffe, and he's got a completely different idea that the universe, that electromagnetism, that the electric fields and magnetic fields, and this is more important than your gravity and your idealized mathematical equations. And the physics community didn't buy it at all.
Yeah, well, it describes reality and physical phenomena, and the reference frames and all of that is not reality. It's thought projects.
What are those circles there around the Birkeland currents or whatever?
Those are magnetic fields that are generated by the current.
Oh, okay.
Yes. Let me ask you the questions about Lorentz transformation. You know, there is a speed of light. Nobody can explain me what does it mean speed of light. Nobody. Tell me anybody. What does it
I can
mean
explain.
speed of light?
Well, I mean,
It's-
that light travels at a given velocity. I thought you agreed that light does have a velocity, even if we can't know it.
No, it's the
I mean-
maximum. It's the maximum movement of electromagnetic waves.
Well, I mean, given that a vacuum doesn't exist, and they say that light is 186,282 miles per second in a vacuum, even if vacuums don't exist and it's slowed down through water or just whatever element, that's still a velocity, though. I mean, I would
Okay,
think.
guys, first of all, what does it mean light? Speed of light, light. What is it?
Electromagnetic waves. Vladimir?
No, electromagnetic waves, it's Maxwell equations. But light is not Maxwell equations. It's light. We can see
It's a
with
part
you.
of the
That's it. Simple
spectrum
like
that is
this.
visible to the human eye. It's a bit
Yes.
anthropocentric.
Let me ask you the next question. We have Lorentzian transformation. It's good. But we apply speed of light to radio waves. All our experiments, all our instruments based on electromagnetic waves named radio waves. How we can apply speed of light to radio waves? And what is the most important? So many times I repeated the same story. There are some named fast radio bursts. It's electromagnetic waves, radio waves. They have a dispersion. There is no constancy of the speed of light of electromagnetic waves. There is none.
Everything you're talking about
And
is
nevertheless,
electromagnetic
we're talking
waves.
about Lorentzian transformation and all this stuff. It's mathematical tricks. There is no physics behind it at all because there is no name light. What does it mean? And what is important? Electromagnetic waves, they have a dispersion, immediately have the different speed of electromagnetic waves. What the meaning of this Lorentzian transformation? It's bullshit. It's mathematical
I,
trick,
I
and that's
already
it.
I already explained that it has to do with the change in the transformation of the units of measure and the
Absolutely right.
coordinates of measure.
Yeah, that's it.
Well,
Simple as this.
it was arrived at because Lorenz believed in an ether, though. Like with the two-way approach, when you shift the Michael-Morley experience, the interferometer, two different ways. That was why I came with length
Okay.
conduction.
It's okay. But I'm asking in principle. Light, what does it mean? I have no clue. And if there is an ether, there is a different speed of electromagnetic waves because of the ether. Simple like this.
Well, he
Okay,
thought
Yeah,
that he thought
Speed
that
of
light
light
traveled.
you can introduce for vacuum only. Vacuum. There
let
is no
me
ether.
let me interject here. Dr. Zapffe actually tried to address this issue in his paper, and he says that the speed of light is basically defined by the epsilon and mu zero of the medium.
It's vacuum. It's vacuum. For so
No,
named
he's
absolute. Uh-huh.
but Dr. Zapffe would say something like the medium of the Earth, the Maxwellian field, the environment of the Earth defines the speed of light by the parameters E and mu
It's wrong.
zero.
Because each planet has their own electromagnetic waves and sphere, Maxwellian, and so on and so on. Doesn't matter. He is
Yes, but
absolutely right that all the different planets, they have a different electromagnetic field around. That's why it cannot be absolute frame of reference. And I told you many times, I don't like frame. There is a space. That's it. There is a medium. Medium, this is a value of our, so-named absolute frame of reference. No, it's medium. Any place you measure, you will have the same result. That's it, simple like this. You don't need this frame. You don't need Lorentzian transformation at all, guys. It's mathematics helping you to calculate something. There is no physical meaning behind of it. I am not against this formula, equation, because you need to calculate something, but don't put any physical. Simple like this.
well, I would like to respond there to that idea. I did in the second session already. If the physical constants, like the speed of light, are determined by a locality, a system, or the magnetic field around the Earth or in the sun, around the sun, if you will, if that is at least influenced in that local system where everything is connected to each other via the electromagnetic forces, then I could see that is also an explanation for what we call a redshift, another isolated system. At least that's how I see the atoms also. But then on a cosmological scale we're talking about now, so galaxies or solar systems, because they're isolated, they can have slight differences in their fundamental nature's constancies, like the speed of light. At least I find the idea at least fascinating in cosmology terms to explore this, because I understand that this is not a fully developed idea that is being put forth here by the man, but is there a reason to deny his work, or to deny his paper publishing, or to offer him, a podium to put forth such a revolutionary thinking that is, of course, not in line with the Einstein's relativity and whatnot, but that is where the resistance comes in, which everybody pointed out, or what was pointed out, the resistance, or that the fact that he doesn't write a proper paper, or he can't do this, or the idea is not developed enough. They are simply excuses to ignore him and to do away with him. I think the red line here, or the common thread for so many people throughout history, is if you come along and you don't whistle the tune of the mainstream, and God forbid you have something realistic and good to say, then it becomes a problem, because now you become a threat to their house of cards system, if you will, right? If it's made up of many distorted conceptual thinkings or erroneous thinking in the logic, etc. And here comes along, like was said, a good, proper thinking genius type. Yeah, of course you're going to be shunned. He's going to be a threat to all those people that have a stake in that house of cards.
Right, you are talking about emotions. Let me come back to Maxwell equations. When Maxwell equation, he put in here, C in his definitions was electrodynamic constant. There is no speed of light in his Maxwell equations. None.
Hey,
Electrodynamic constant
Vladimir,
means
Vladimir, this is what Carl Zapffe talks about in his paper, exactly what you're saying. That's why I'm bringing it up today, because
you
he
are
said the
absolutely
same
right.
thing you're saying. Read
I
his
like
papers,
it.
read his
I
papers,
like it
read
very
his
much.
papers,
There is
read
no,
his
in his time,
papers.
there was no speed of light, electrodynamic constant. It is absolute
Stop.
electric charge
Hold
to
on,
absolute
hold on.
magnetic charge.
One of his arguments against the Einstein theory is he says that you can't define the speed of light in an inertial frame because an inertial frame has no physics. It has nothing. It
Right.
doesn't
We
exist.
are talking
How do
about
you
what?
define physics in an inertial frame? How do you define the speed of light when there's nothing physical there?
Yeah.
You see, he was genius. He was genius. He was metallurgist or whoever, but he was genius. Absolute time, absolute space. Maxwellian field means microwave background radiation, and there is no speed of light notion even. Guys, how many times I repeated the same? We must stop talking about special relativity, general relativity, because this is a mathematics only. There is no physics behind these equations. No physics.
No, but
It
the
helps you
difference,
to
as far as I
calculate
can
something.
see,
Well, that's the
that
promise here, is it not?
Zapffe did conceive of the possibility of defining a speed of light within an electromagnetic field, whereas Vladimir says it's a meaningless concept. I think that there's no commonality between the two there.
And when you have a different medium, suppose a cosmic medium or your ether, you must put additional two parameters, electric parameter and magnetic parameter. And you can calculate your speed of electromagnetic based on zero multiply epsilon, mu zero multiply mu. Only then you can put some speed of electromagnetic waves depending on the parameters of the medium. And you can name it Maxwellian field, microwave background, it does matter. Does matter, there is ether, and you have some parameters of this ether. If you will take into account this epsilon and mu additional, multiply on epsilon zero, mu zero, then you will have your speed. Really, you can measure it. Simple like this.
Well,
Guys.
all I know is that radio waves all the way to gamma rays, including the visible light spectrum, are all photon emissions from suns and plasma clouds. Clouds of plasma also give off light. They also give off radio waves. They also give off X-rays. They also give off gamma rays in certain conditions.
I talked already with you about photons. They don't have wavelength. How with one photon you can
Oh,
transmit the
the
radio
elect
wave with wavelength 10,000 kilometers? Let me ask you the question. The last time we talked about, and you're coming back to the same story. Don't name photon. Photon, there is no meaning for Maxwell equations. Because Maxwell equations, it's a classical physics, and photons, it's a quantum physics. You know, guys, I repeated my point so many times, and I didn't achieve my goal even with you guys. How I can go to the famous scientists and trying to convince them if I cannot convince you?
Well, we know
Guys, we are
photons are real.
dissidents. Nevertheless, we are repeating the same story many times. How many times? One more time, we will talk about this speed of light and photons and all this stuff. Photons, it's a quantum objects. What does it mean? Radio waves or something. It's ensemble of photons, ensemble of electrons, all this stuff. In antenna, you don't have each electron. You have your currents, and you can generate radio waves by currents, not by photons. Please stop naming even photons. We are classical physicists. Photons behind of it.
It's been proven that light creates matter, creates an electron. It's been shown, and it's been theorized in the 1930s
there is
by
no
two
matter
physicists.
generated. There are some electrical currents. That's it. Be physicist. You know, I'm still out already with all these common words, guys. We are physicists. Let's name definitions by physics. Physics, not emotions, not your view of something. There is physics, there are Maxwell equations. I told you many times about the same, and nevertheless, I didn't achieve my goal. I'm sorry.
Okay. Can I make a comment? I view Maxwell's theory as incomplete because in the Einstein's gravity, he shows that light refracts around large masses, well, he doesn't say refract. He says space has redefined the length scales and the whatnot. So that it's an exercise in changing of length scales and speeds without that happening. So, but anyway, if you want to go back to the classical idea of refraction, you have to have that mu naught epsilon naught changed by the gravitational field at the very least. But no one's ever really done that properly. And there's no definition of what an epsilon mu naught should be in a gravitational field or a changing gravitational field. And then on top of that, if once you change those basic constants, it changes all of electromagnetism at various points away from a planet. That's my view, anyway. I know Vladimir's shaking his head already, but
no. I will tell you. I will
let's-
give you explanation.
Hold on.
Okay.
The point here, the point here is this is an issue that Carl Zapffe raises. Okay, and he talks about this in his papers, but he doesn't go into it in detail. And you can understand the problem is there's all these issues, okay, that are not really well defined. And he's trying to say to the physics community, these are issues that you need to grab a hold of and deal with, but they don't want to. Okay. And so for the purposes of this discussion, my suggestion is I encourage you to read his papers and try, maybe you'll find that he agrees with you or he has ideas that you think you can develop further. Okay. And I think Vladimir has a point. He does bring up this issue that the speed of light is the ratio of the permittivity to the permittivity.
Well, the product.
No,
The
a
ratio is
little
the
bit different.
impedance.
No. it's you have two systems, electric and a magnetic, and you have charge in electric definitions and magnetic definitions, and you have your ratio of these charges in different magnetic and electric fields. Simple like this. And what is important, it was measured, this constant was measured before Maxwell equations, before he put
Right.
it inside
Dr.
based on
Zapffe,
speed.
Dr. Zapffe talks about this in his papers. He specifically talks about the Weber-Kohlrausch experiment and how
Yes,
that's the
yes,
definition of what the light is.
yes, yes, guys. That's why there is no speed of light. And James, let me talk you about this aberration around sun, around sun. Let me tell you that around sun there is so named solar corona. When you have your solar corona with size 8 times bigger than sun itself, you have some index of refraction, and there is no gravitational field change of it. No, there is an optical effect. You have your different index of refraction for radio waves or light waves around sun in this prism. It's a prism. Index of refraction different from the of the sun to 8 radius of the sun. You have some medium here, and you have your light electromagnetic wave going through this prism. It's well known. Many times I talked about it, I published this result, and nevertheless, we're talking about gravitational change of something. No, electromagnetic waves, it's an electromagnetic phenomena only. And
Well,
prism,
maybe.
not maybe, it's well known.
No,
Guys,
no,
you don't know
maybe.
about solar corona at all?
Maybe.
Unfortunately.
I think what we
Maybe.
have here, we're really talking about issues that aren't resolved in modern
Yes,
physics.
yeah.
And if you object to the term photon as being a quantum phenomenon, well, let's use the classical Newtonian term corpuscle. Now, Newton actually calculated the deflection of a ray of light using Newtonian mechanics and assuming corpuscles without knowing about mu naught or epsilon naught. And he calculated that, and it turned out to be 1/2 of the value ascribed to that by general relativity. And I would maintain, for one, that the Eddington experiment of 1919 did not differentiate between the two. The orders of errors were so great that the value was somewhere
Yes,
between the Newtonian and the Einsteinian value.
you're absolutely right. That's why, all these bullshits. And we put as a, I don't know, as a religion right now, religion. We believe in everything. There is no physical meaning behind at all. It's simple like this.
You're right,
You're
Ian.
absolutely right. By the way, null experiment for more Maxwell equations, it doesn't matter, experiment. It was wrong. Never it was zero. Never. Never. Check all these attempts to measure zero or not zero. And most of these experiments, no zero. Nevertheless, they put as the main point, there is a zero result of this experiment. That's why flight of speed constant. Bullshit. It's against experiment.
Yeah,
Against.
and I think the Michelson-Morley experiment wasn't sensitive enough to even detect the ether, like Ian says.
Well,
it does matter. What does matter? There is no null result means there is no constant speed of light. None. Because it's contradict to experimental result, even based on their ideas.
Vladimir, what I object to the way you express things sometimes, because you should say, if such and such is true, you should be able to see consequences. And this is the way we should talk a bit more about. So if gravity affects light, it should affect other things, and we should see it in this effect. So I would say saying everything's bullshit is counterproductive to thinking. I know you're an expressive person, but that I would just calm down your rhetoric a bit, I would say, and trying to think about what the consequences of your thought and whether you can prove it or not from a consequence or a corollary, as Newton did with all his corollaries and ideas. That's my point on your expressions. Okay.
Well, what we have here is we have essentially a lot of unresolved issues that people are not convinced they're resolved, and the mainstream is saying they are resolved. But to us, we can't even agree on on our opinions about them.
Guys, all the ideas must be based on experimental results. If you have some idea, tell me immediately what is the experimental result behind of this idea. Simple like this. I am experimentalist. I develop my model based on experiments only. That's why I'm physicist. Physics means parameters, measurements, correspondence between your ideas and results, experimental results.
We
Not
do that at
ideas, not religion, results.
we do that in the electric universe, Vladimir, but we say that these experiments done in a laboratory are scalable, and the mainstream, do not believe that these experiments that are done in the lab are scalable out to the galactic size, out to the cosmic level. It's nonsensical when you understand that there's currents out there. They're starting to admit to current out there, and when you look at current happening here in experiments on in the lab, they recreate craters within craters, craters on the edge of craters, cliffs, bluffs. They turn stone or clay into particles like instantly. Electric discharge is how the universe works, and nobody
No.
sees this.
Let me tell you one more time.
I would say that much of science didn't involve directly experiment. There's much that you can see through reason and observation. I mean, just the concept of absolute space or time, or
Yeah, but we can show things that
Well,
happen on a solar system scale, on a galactic scale, right in the laboratory, and they discount it and they dismiss it, saying no, that's
I
not
would
proof.
I would like to bring it to a
One sec. Let me
philosophical
continue. I'm
level
sorry,
again.
Edo. Let me finish my speech. One sec. I have nothing against electric phenomena, electromagnetic phenomena, and all this stuff. But let me tell you guys this story. Only 2.4% of matter of our universe, they name it universe, world, is usual standard material, standard. All your radio waves, all these photons, electrons, all this stuff, only 2.4%. How you can build any theory of the whole cosmology of the whole universe based on 2.4% of matter? Guys, it's a
We don't.
totally different
We
story,
we
and it's
we know.
accepted
We
even to
know
your
that the
electric phenomena. All the
we no
stars,
no no
all
in
the
the electric
galaxies, they
universe,
have top. By the way,
dark
have a
matter,
respect. Let me
dark
finish.
matter.
Oh my God.
Sorry, dark
I'm not
matter and
talking
dark
about dark
energy
matter.
don't
I'm
exist in
talking
an
about
electric
now
universe.
standard result, experimental result, that only 2.4% of matter inside of galaxies, stars, electromagnetic waves, and all this stuff.
That's
How you can
incorrect.
build any theory of universe based on 2.4% of matter?
But
Let me
that's
ask you the question.
incorrect. That's incorrect.
So,
That
I want
thought
to
is
hear what Ido has to
incorrect.
say.
Go ahead, Ido.
well, it's more a question to you all. Do you guys think that Socrates, the philosopher of old, that he was a proper scientist?
Sorry, who was that?
Socrates.
Socrates.
Oh,
Socrates.
Socrates, yes.
Socrates.
I wouldn't say he was a proper scientist, though I would say his approach definitely led to science. Absolutely.
Okay. Well, he did good work, yeah. So
He was a
why did he have to commit suicide?
I think they killed him.
Good
Why?
physical
He drank the
question.
hemlock.
Why?
He
Why?
insulted
Because
the audience. He insulted the town.
he
I mean,
went against
they
the
probably would have let
prevailing
it
religion.
be if he had been more
Why?
accommodating.
he was
What do you mean?
corrupting the youth.
That's right. Yes.
He was corrupting the mind of the youth. At least that's the phrase that I remember. Yeah, that's the only thing I remember about it. But what I'm trying to point out is we're all a little bit Socrates here, and we are very lucky we don't have to drink the poison cup.
Correct.
I mean, this is
Well,
what happens
I've
when you
pointed
go
out
up.
that metaphorically we do. We don't have to drink the poison cup, but if we're a bit younger than most of us here and we have careers to advance and so on, we are dismissed from those and we're not given the opportunity. I don't want to be, victim talking, but
Blackballed.
No,
so
but
in other words,
yeah.
we're not physically put in the middle of the market square and burnt at the stake, but we are metaphorically. Burnt.
Well, I wholeheartedly agree. The times of quarterning, I think is the term, or burning at the stake, or poison cups, or all that kind of stuff is over. It has been replaced by other things. It's still like we call it in Dutch in the ban, putting somebody in the ban, the churchly ban, meaning you are cursed and nobody is to associate with you. And it's like 2 pages long of utter condemnation, right? And that is more or
Excommunication.
less still happening. So I hear all you
Excommunication.
guys' arguments, and we need to do better. And there are people out there that have good proposals and whatnot. And I think it's very important what's happening here. I just like to point out there are people in power and they don't like what we have to say. That is why you call yourself dissidents. And I'd like to think of myself as one. Thank you.
That's good. I like that. Thank you. Um, let's see, we're getting down to about 5 minutes. Okay, so essentially, by bringing up Dr. Zapffe, I think he brings up a lot of these issues that people feel strongly about, and I think what it means is we don't really have an agreement amongst ourselves necessarily, but these are unresolved issues in our
Yeah.
minds.
So,
What is a
Harry,
photon?
just before we end, so the literature you've got is there's a reminder on EMC squared 1983. That's the main book. Is there? Have you got? I've looked online. There's an Einstein-Lorentz transformation document that doesn't appear to be in libraries. Have you got that, or you referenced that?
It's hard to say because if you see here, I
Yeah.
got there's a whole bunch of stuff here.
So that's
Okay,
his.
and
That's his
there's
manuscript typescript.
this is the copy of it that was sent to me by Jack Flanagan Graham, who is I
Yeah.
don't think this
Well,
is
it
in
doesn't
focus.
focus on the text.
It's
I
being
can't
it's
see.
being blurred because you have your background blurred, Harry.
Yeah, I know. I should turn that off, but yeah, okay.
So what does
Anyway,
it say? The title?
there's a 7 short essays. I don't know. It's called the 7 short essays. Now, there's a whole bunch of papers that have been published in obscure journals. There's the Indian Journal. There's this journal called the Tooth Mahan Review. He's got papers published, and and these are kind of like I think they're probably some of them are probably defunct, and probably they're not cataloged by the people who do scientific catalogs and stuff like that.
You might
Um,
find some of his papers through a Google search. So
yeah, I
Good.
didn't mention this, but one of the things that I did was I went and I consulted with a number of different AIs. And essentially, the best AI was Grok, believe it or not. And I got one AI that said that no such person as Carl Andrew Zapffe existed.
This is
So,
the meaning of I. Forget it. It's Orthodox. All of them Orthodoxes because they were trained by Orthodoxes. Simple like
correct,
this.
correct. I agree, and that's why I object to Roger Anderton.
Yeah. Oh, yeah. It's a very good assistant. I use it. Assistant, but no meaning, no physical meaning at all.
Right. So we need
yeah,
to be
it's
careful.
AI isn't smart enough yet to be able to rely on it to even give you good data. It sometimes gives you false data as well.
It
You
doesn't
have to be
calculate.
Yeah.
very careful with
Oh, yeah.
AI.
Oh,
Anyway, the point,
It doesn't calculate.
point,
It gives answers that it plucks it out as text, right? So the answer in a calculation, it treats as text. So you can get completely wrong simple formulas and it will state, no, it's correct. And you go like, well, 1 + 1. No, it's not free, right? And no, yeah, it's free. It doesn't even
right,
calculate. It's not smart at all.
this is a different topic of conversation.
Right.
The point I'm making is you should be probably you by consulting an AI, you should ask for references and or if you can do Google searches and that sort of thing. I'm not sure how successful you should be. The only AI that actually quoted my papers on Carl Zapffe was the Grok AI, and the rest of them apparently didn't even were aware that I'd written papers about Carl Zapffe, and of course the one AI said there was no such person. And anyway, and then another AI got his name wrong, called him Carl Alfred Zapffe. Okay, so we got some food for thought. We had lots of conversation, lots of things to discuss.
Do a search for Dr. Carl Zaffe's papers, and you should get some decent results.
Yeah, you can search on Google Scholar, or there's a thing called WorldCat, which has is a reference of all the world's libraries, and there's a few books there that are, although not many of the stuff that we're talking about, mostly is metallurgy and other things. Yeah.
Okay, I brought this up because I thought would be interesting to people, particularly about the electric universe, and I think we agree that he does have some ideas that would be consistent with the electric universe ideas. He
universe. Electric phenomena, yes. There is no electric universe. 2.4% overall ordinary matter. What kind of electric universe we have? Please, electrical phenomena around all the planets, all the stars, always right. You're
I think you're
absolutely right about this phenomena in craters, in suns, in planets. I do like it very much, but don't transfer this knowledge to the whole universe. This is my point.
The only thing that we can't
I
detect is neutrons, and everything that we see, and some of the stuff that we don't see with our visible eyes or radio or anything like that, it's still just the universe, and there's no need for dark matter or dark energy. It what we see is what we get.
Well, the point I'm making here is I shouldn't have said the electric universe. When I refer to that word, I refer to a group of people who espouse this idea, physical idea. But I think the point is that Dr. Zapffe is saying to the physics community, you need to look at physics.
Electromagnetism.
You need to look at physics from a different point of view. You need to look at it as a kind of a holistic idea. You're looking at it purely from an ideological concept of mechanical frames of reference, inertial frames of reference. This is not the correct way to be looking at the universe. You've created this abstract ideology of mathematics, and you're trying to make the universe agree with this ideology of mathematics. It's not real physics. He's saying you need to look at the real physics of what's going on. That's what I think his message is, and I don't think that message was at all well received. That was his second discovery, was that the physics community didn't want to hear what he had to say.
You're
Because
absolutely right. Thank you so much, Harry. I didn't know anything about this famous guy, maybe. So good ideas he had, genius guy. But nobody wants to accept it because he was against religion. And religion, mathematics, it's not physics. Simple like this.
Okay, we're going to get
Good
off of
presentation,
here.
Harry.
Thank you. I do want to encourage other people to make presentations.